For this video, we are going to be reducing radicals. So, some of these examples that you'll see, there will be a negative inside of the square root. So remember, we've been talking about real numbers. A real number is any rational or irrational number. If you have something that has a negative inside the square root, that is called imaginary, or I for short. A complex number will be a number with both real and imaginary parts, like a plus bi from the sum of squares from earlier. So let's go ahead and see an example on this on simplify radicals. So again, you're still on page 8 in your little quadratics book. You're going to simplify the square root of negative 8. So first you're going to see if you can pull out, well, for one, you can pull out a square root of negative 1, which we just said was the letter I for imaginary. And then you have square root of 8 left, and then you're going to see if you can pull out a square, a perfect square. So we'll look at 4 first. Yes, we can pull out a 4, so a square root of 4, and then we have square root of 2 left over because 2 times 4 is 8. So the square root of 4 is 2 because it's a perfect square, and then the square root of 2 is just the square root of 2. We'll leave it that way since it is an irrational real number. So our answer is actually a rational number 2, an imaginary I, and an irrational square root of 2. That would be your simplified radical form. So let's go ahead and try a few more examples. So square root of 56. So go ahead and pause the video, see how many perfect squares you can take out of here, and reduce it as far as you can. Okay, so we're first going to try to pull out a perfect square. Well, let's see if 4 goes into there. 56 divided by 4 would be 14. Okay, so the square root of 4 is 2, and then square root of 14, you can't pull out a perfect square. You basically have square root of 7 and square root of 2, which those don't actually help any, so we're done there. So we have 2 times the square root of 14. So our reduced form would be 2 radical 14. Okay, try the next example. Remember, the square root of negative 1 is I. Okay, so we know that this is negative, so we can pull out a square root of negative 1, which we know is I. And we're done with that part. Now we have the square root of 16. The square root of 16 is a perfect square. It equals 4. So we have 4 times I. So our reduced form would be 4I. Okay, now see if you could try the last example. Go ahead and pause the video, pull out all the perfect squares, all that. Okay, so we have a negative again, so we could pull out square root of negative 1. Again, that is our I. And then the square root of 24. We're going to check our square, see if we could pull out a perfect square. 4 looks like a good one. So we pull out the square root of 4, and then 4 times 6 gives you 24. Square root of 4 again is 2, and then the square root of 6, if you want to break it down some more, is square root of 2 times the square root of 3. Again, 2 and 3, neither of those are perfect squares. You can't pull out perfect squares, so again, we're just going to go back a step for that one. So we have an I left over, a 2, and a radical 6. So our reduced radical form is 2I square root of 6. And that would be our answer. Remember, if 4 doesn't work, try 9, try 16, try 25, just keep going.